Okay, well, good morning, 8th grade. I hope it's going well. Today's lesson, just to give you a heads up, is going to be a little bit longer. It's 11.5, and this is now when we are multiplying radicals and actually dividing, but multiplying the radicals. Okay, you guys have been, I think, doing a pretty great job with the radicals from what I graded earlier. I haven't graded all of it, but working on that. So I'm on page 470. You will want to turn to page 470 to watch what's happening. I don't know that they do a great job of explaining it, but it will help you understand the concept. Okay, so if we had the radical here, the square root of 4 times the square root of 9. Okay, think about this. If we simplified this one, what would that be? That would be 2 times, and we simplified this one, that'd be 3. So 2 times 3 here is 6. Okay, that's easy. You guys know how to do that, simplify and then multiply. Now let's say, instead of doing this, we decided to instead actually multiply this guy times this guy. Well, what's 4 times 9 is 36, right? The square root sign stays. What's the square root of 36? Look at that. It's the same answer. Gets you the same thing. So the point is we can do either way. Okay, so the way we would rewrite this if we want to multiply is the square root of 4 times 9. And that leads to the square root of 36, which then leads to the answer of 6. Okay, we can do it either way. It doesn't really matter. So let's see when they give us one that's a little harder. Here's our rule. Just so you know, the square root of A times the square root of B is equal to the square root of A times B. Okay, if you want to write that down, it's very important. So let's see one of these in practice. Okay, what if I had over here, if I had the square root of 24 times the square root of 54. Okay, when I see that, I can multiply that on my calculator. Okay, so I type that in, I do 24 times 54, and I get the square root of 1,296. Now, when I take the square root of that, I actually get the perfect number 36. Okay, so by taking these numbers here, and this is calling this A, matching this A, and this B, matching this B, I just did A times B, and I got A times B, and I got 1,296, and then I took the square root of that and got 36. Now, the sad part is that often it doesn't come out this easy, okay? And so I'll show you what we have to do when it doesn't come out this way. Okay, so if they give us something like this is what they also do, is they'll give us something like this, the square root of 6 times the square root of 15. Now, this, if I multiply them together, would be the square root of 90, but the square root of 90 is not a perfect square, right? So this is not really super helpful. Okay, so what I need to do, and this is really weird, is I need to do a prime factorization tree. Okay, so I need to do what's called the factor tree, which you guys are pretty good at doing. So I need to do a factor tree of each one of these. So what is the factor tree of 6? That's getting down to the prime numbers, is 3 times 2. And what is our factor tree here? 3 times 5. Okay, now what I do is I'm looking, all I'm looking for is matching numbers. Okay, and I see that here's a 3 and here's a 3. Now think about this. What that would be when these are all multiplied together would be 3 squared. Remember how we would rewrite this? Times 2 times 5. Now think about this. If I take the square root of all of these, right, what's going to happen? The square root here is going to get erased by the squared, and it's just going to become 3. But these square roots here are going to stay, right? But what is 2 times 5? Right? I can do my thing, and I can get the square root. That's going to equal the square root of 10. So my final answer is 3 times the square root of 10. Okay, so that's just a brief introduction, so we'll launch into that. So how else is this helpful? And we'll come back to an example like that, so don't worry if that was a little confusing. But if we do an example like this right here, what if they give us the square root of 240 and they say to simplify that? Well, I'm going to do my prime factorization here, right? So I'm going to say, okay, it ends in a 40, which I know because of doing stuff is divided by 20, right? If it ends in 40, it's a multiple of 20. So I come to my calculator and I type in 240 divided by 20, and I get 12. Okay, so now I just keep going with my prime tree, right? I get 4 and 3, which is 2 and 2. You guys are good at this, right? 10 and 2, 5, and 2. Okay, so what am I trying to do? Now I have to circle up my pairs, right? So here's a pair, 1, 2. It doesn't matter which tree they're in. Here's a pair, 1, 2. Okay, so there's my pairs. Now what do I have left? I better circle him, right? The green is a 5 and a 3. So that means in the square root sign, I'm going to have 5 times 3. And outside of it here, I have 2 squared there and 2 squared there. So when I take the square root of that, that becomes 2. Take the square root of that, that becomes 2. So then I have 2 times 2 on the outside. So what is 2 times 2? Well, that's 4. What's 5 times 3? That's 15. So my answer is 4 times the square root of 15. So whatever does not have a match goes inside the square root sign. Whatever does have a squared match comes on the outside. Okay, so I'm going to write match. I'm going to write solo, right? If he's solo, he goes inside. If he has a match, he goes on the outside. Okay? So what if they give us a smaller number here, like 72? Right? All we would do is say that's 12 times 6, which is 3 and 2, which is 3 and 4, which is 2 and 2. Okay, so I'm looking for direct matches, right? This 3 has a direct match, and these 2's have a direct match. What does not have a match? This guy, he's solo. So he goes inside, right? Because he's solo. This is our solo category. Now, these guys here are 2 squared, which when I take the square root of 2 squared, it is 2. So I know I'm going to have a 2 out here, times, and then these 3's, that's 3 squared, which when I take the square root is 3. So 2 times 3, which is 6 times the square root of 2. So these guys are match. And this guy is solo. And so I get 6 times the square root of 2. Okay, so that's just using your prime factorization trees. You guys can do it. I believe in you. So you guys have got that one. Okay, that's just going to take practice. So let's do another one. Square root of 162. I'm going to divide that one by 2 because it's an even number, right? So if you don't know where to start and it's even number, just start with 2. 162 divided by 2 is 81, which is nice because I know 81 is 9 and 9. And you see I can stop right there because I know all I have to do, right? Here's my matching pair, 9 and 9. And this guy doesn't have a match. So I write the answer 9, right? This is the match times the square root of 2, which is the solo. And I have 9 times the square root of 2 as my final answer. Okay, so not too bad. Another thing that we can do here, and this is weird, is if they give us something like this. Let's say they gave us the square root of 14 times the square root of 21, right? This is, back to our first example, 7 and 2, 7 and 3, right? Again, matching pair, 7, so that's 7 squared, square root equals 7. And what am I left with? A 2 and a 3. So I have 7 times 2 times 3, which is 7 times the square root of 6. And that would be my final answer. Now, one other thing that we can do, and this is interesting, here's a rule to write down, is when they're multiplied, if we have a times the square root of b times c times the square root of d, guess what? We just keep what's on the outside multiplied. This equals ac times, and then we just multiply what's inside and keep it inside, bd. Okay, so let's do an example like that. Let's do this one, 2 times 54, or sorry, 2 times the square root of 54 times 3 times the square root of 15. Okay, so this one's quite easy, right, to do on the outside part. We take 2 times 3, that's 6. So we know 6 is a match, he's outside. Now we got to do our prime tree of this guy. 54 is 9 and 6, right? And this one's 5 and 3, and this one's 3 and 3. And this one's 2 and 3. Okay, so now I say, what do we have matching here? I have 1, 2. There's a matching set of 3's, right? So that's going to give us another 3. Because that's 3 squared. Then I have 3 and 3, so I'm going to have a times another set of 3. And what do I have by myself? This red 2 and this red 5. So inside, so solo is 2 and 5, so that's going to be in the square root. And out here I have 6 times 3 times 3, right? Why did they come out? Because they had perfect matches. So what's 6 times 3 is 18. 18 So this is 18 times 3, which is now 54. So my answer is 54. That's on the outside, right? They had a match. Times what was solo inside was 10. 54 times the square root of 10. Okay, if you want to look at how they did that, this is example 7. Okay, sorry, I should have mentioned that. Example 7. Okay, so that's pretty important to understand. You guys can figure that one out, I'm sure. You just use your properties of deduction and you got it. Now the next rule, which I don't know why they're teaching this in this lesson, they're going all the way in here, is quotients, okay? So if we have the square root of a divided by the square root of b, that is the same thing as the square root of a divided by b, okay? The order doesn't matter when we take the square root. So if they give us this, or if they say, let's do the square root of 25 over the square root of 4, that's the same thing as 5, right? We take the top one, 5, and the bottom one, 2. We have 5 over 2. Now, it doesn't matter if that was written this way, or if they would have written it like this right here. What if they would have wrote the square root of 25 divided by 4? Well, we don't have to divide first. We could rewrite it this way and get 5 divided by 2, right? Because we can write it either way, we get the same answer. So, like, for example, if they write it this way, they say the square root of 45 divided by the square root of 5. Well, that's not very helpful, right? Because I know 5 is not a perfect square. So I need to go the other way and do the square root of 45 now divided by 5. What's 45 divided by 5? Well, that's 9. So now I got the square root of 9. And what's the square root of 9? That equals 3. Okay, so you just choose whichever order actually you have a perfect square root, and then you're good to go. So that's pretty much it. Pretty straightforward. So like if they did this one right here, they said the square root of 18 divided by 9, right? I could take the square root of the bottom one, right? I could take the square root of 9, but that's not going to be helpful because I can't take the square root of 18, so I'm not going to do that. Instead, I'm just going to divide. What is 18 divided by 9 is 2, and then this is my final answer. It's just the square root of 2. Okay, so I can leave it like that. Or, and I'll do one more here, if it looks like this, the square root of 8 divided by the square root of 2, okay, that's not helpful because neither of these are square roots, so I need to rewrite this as the square root of 8 divided by 2, right? Does everybody understand? These two things are the same thing. Okay, there's no difference. We get to choose which if we divide first or take the square root first. So what is 8 divided by 2? Well, that equals the square root of 4. And what's the square root of 4? That's pretty easy. The square root of 4 is 2. And so that is our final answer. Okay, so most of the time it's going to be better to just do whichever one. If you can't take the square root of that, then you put it out and divide first. Okay. Wow, that was a lot of information. So I hope you all tracked with that. Here is our lesson. It is page 473. Okay, this is 11.5, and here's our homework. We're going to be doing 1 through 31 odd. Okay, I know you guys are getting tired. It's been a long school year. It's been hard with quarantine now to stay focused, but you guys got it. Hang in there. We're almost to another weekend and almost into our last week. So well done, and I will see you all soon. Mr. H, over and out.